This video covers topic 3-1 over relations and functions, day 1. The bell work asks us to label the following parts of a coordinate plane: the x-axis, the y-axis, the origin, and the quadrants. So the x-axis, it goes left to right, which would be this arrow. The y-axis goes up and down, which would be this arrow, I believe. The origin is directly in the middle, and I think that is what this arrow is trying to point to. Specifically, the origin is right here at 0, 0. The quadrants, one is in the same place of a clock. So if you've ever looked at a plane, like a circular clock that we have in school, one is in the top right corner. That's the top right quadrant as well. And then the quadrants go in the opposite or counterclockwise. So we're going against the clock. So 1, 2, 3. I'm just trying to make it dark enough so you can see it. And then 4. So, sorry, I guess this needs... So 1 is up here, then 2, then 3, and then 4. For the examples, they ask us to plot the following points and tell what axis or quadrant the point is located at. So M is at 2, -1, so this would be M right here. That is going to be in the bottom quadrant, which is quadrant 4. N is at -3, -3. So negative, negative means I go to the left and then down. N would be in quadrant 3. If you're struggling with graphing, you might want to write some little notes to yourself. This is your x-axis. On the x-axis, right is positive and left is negative. This is your y-axis. On the y-axis, up is positive and down is negative. So if it helps you to write these things so you can figure out where to go, that is totally fine. R is at 0, 3.5, so that means we're not going to go anywhere left to right, and then we're going to go up 3.5. So that puts us at R. R is on the y-axis. We don't go anywhere left or right, we just go up 3.5. And then if you need it, right 2, down 1, left 3, down 3. T is going to be right 5 and then down 2. So we go to the right 5 and down 2. So T is down here. T is also in quadrant 4. B asks us to go to the left 3, and then the 0 means we're not going to go anywhere up or down. So we go left 3, which would put us on the x-axis. Again, if you need to see it, it's on the bold line that is going left to right, which is your x-axis. W asks us to go left 1/2 and then up 1. So we would go left 1/2, up 1. That's the point W. That's going to be in quadrant 2. Excuse me. 0, -2 means we're not, excuse me, we're not going to go anywhere left or right, but we are going to go down 2. And that's point X. So X is down 2, which would put us on the y-axis. And then 5, 7 would be right 5, up 7, positive, positive, so right and then up. So that would be L, and L would be in quadrant 1. Now we have some vocab here. A relation is a set of ordered pairs that can be expressed in 4 different ways. It can be an ordered pair. It can be in a table, it can be in a map, or it can be on a graph. And we're going to see all of those. Domain is a set of first coordinates in a relation, so all of the x's, where range is a set of second coordinates. Which would be all of your y's. A function is a relation in which none of your first coordinates repeat. All of the x's are different. So for a function to be a function, I want you to think about a relationship where people break up, they get back together, they break up, they get back together, they break up, they get back together. That is not a healthy, functioning relationship. If you break up with someone for a good reason, then you need to stay away. And that is a function. A function is a good, healthy relationship. So if you have a function, an x breaks up with someone and is not repeated, you do not go back to that same x. All of the x's are different. For a function, y's do not matter. So your y's can repeat all day long as your x's don't repeat. For example 1, they want us to list the domain and the range. So remember, your domain is all of your x values. So we have 2, and you do have to put the braces. We have -3. We have 0. We have 5. We have -3, but we've already written it. In domain and range, you only write it once. We have -1/2. And then again, 0 and 5 are already written down. Now, because I have an x of 5 that repeats, -3 that repeats, and 0 that repeats, this would not be a function. Without finding the range whatsoever, I can already tell you this is not a function because the function, because the function depends on the domain, and the domain has repeats. My range is all of my y's, so my y's are -1, -3, 3.5, -2, 0, 1, -2 I've already written, and 7. So my range has a lot more numbers there. And again, your range is just your y values. You do not repeat on domains or ranges. So when you are listing them out, you do not repeat. For problem 2, they ask us to make a mapping or a table for the relation shown, state the domain and range. I think the table is the easiest part, and I like to start out with that to build my confidence. When you have a table, you are basically copying and pasting. So the point 11, -2 is copied and pasted. The point 12, -1 is copied and pasted. The point 13, -2 is copied and pasted, and 9, 7. So all you do is rewrite your points in that table, and that is it. From here, I want to go to mapping. Now, mapping is all of your x's and your y's. I'm going to put all of my x's here and all of my y's here. If they repeat, you do not list it twice. So my x's, I have 11, 12, 13, and 9, and I'm getting that from here. My y's are over here, -2, -1. Now, again, -2 repeats, so I do not put it twice. And then 7. Now, just like in Google Maps, when you look up Google Maps and you type in like a certain place, of I want to go from the school to Chick-fil-A, Google Maps says, okay, here's your beginning, here's your end, and then it takes you through your route. With mapping here, you're going to do something similar. You're going to say, if we start at this X, we will end at this Y, because those are the letters or the numbers that go together. 12 goes to -1. So if you start at 12, you're going to end over at -1. 13 goes to -2, so we draw an arrow back up that way. And then 9 goes to 7. So again, mapping, you have to say start here and end here. So we start at this x and end at this y. My domain is all of my x values, and I put the little braces in there. I'm underlining them in blue so you can see my x's. I have 11, 12, 13, and 9. For my y's, I'm going to have -2, -1. -2 is repeated, so I do not put it twice, and 7. Now, all of my x's, 11, 12, 13, and 9, these are all different, so it is a function because there are no repeats. No x's repeat. All right, problem 3. We start with mapping this time, so I'm going to take it to a table. Remember, the arrows tell you start at 2 and you go to 12. We also go to -3 from 2, so 2 is a little bit of a player because this x has 2 y's. 1 goes to 5, 0 to 0, and -1 to 5. Then they asked me to list the domain. Remember, domain, we do not repeat x's, so 2, 1, 0, -1. And if I haven't said this already, the order in which you write them does not matter as long as you write them correctly. And then your range, 12, -3, 5, 0, and then 5 was already written. This is not a function because your x equals 2 repeats. When x is 2, we have a y of 12, and we have a y of -3, meaning that it repeats. The vertical line test is a method used to determine if a graph is a function or not. If a vertical line passes through the graph more than once, so 2, 3, 4, 5, anything more than 1, then the graph is not a function. Now, when you complete the vertical line test, the x and the y axis do not count as passing through the graph. The graph is the bold part. So on problem 4, when I draw my vertical line, it is touching 1 time. Because it is not hitting more than once, it is a function. On problem 5, when I draw my vertical line, it hits my graph 2 times. 2 is more than 1, so the graph is not a function. On problem 6, when I draw my vertical line, my line hits 2 times, which is more than 1, so it is not a function. On problem 7, my vertical line hits 1 time, so this is a function because it only touches 1 time. Problem 8 touches 1 time, so it is a function. Problem 9 touches 1, 2, 3, 4, 5 times, so it is not a function because 5 is definitely more than 1. Now, problem 10 says a point is missing from the graph of the relation shown. The relation is not a function. Which point is missing? So when I complete my vertical line test, right now this is a function. So I need to figure out what point I could graph on here to make the vertical line test fail because they are looking to make it not a function. If I graph the point 0, 0 and complete the vertical line test, none of these repeat. So 0, 0 would keep it a function, but that's not what I'm looking for. -1, 2, if I complete my vertical line test, still is a function, so that is not what I'm looking for. The point 1, 1, however, if you notice, this, when we complete the vertical line test, would hit 2 times, making it not a function, which is what we were looking for.